In this video, I'll show you how to convert between octal and decimal. The octal number system uses 8 digits, 0 to 7, and therefore has a base of 8. The first question reads, convert each octal number to binary. Let's start with 7,364. To do this, we will start with either the 7 or the 4, it doesn't matter. Let's start with the 4. We'll take 4 and divide it by 2. So 4 divided by 2 gives us 2. Since there's no remainder here, since there's no decimal, we'll write down 0. Now we'll take 2 divided by 2, that gives us 1. Still no remainder, it's a 0. And you stop once you reach an output that's less than 1. So let's go ahead and do it once more. 1 divided by 2 gives us 0.5. To reach 0.5, you'll need a remainder, so that's 1. Therefore, the octal number 4 is read as 100. You always read it upwards. Let's move on to 6. 6 divided by 2 gives us 3. No remainder, that's read as 0. 3 divided by 2 is 1.5. That contains a remainder, so we read it as 1. And finally, we use the integer portion of the number. 1 divided by 2, that gives us 0.5, another remainder. This number is read as 110. You always read upwards. Next we have 3 divided by 2 gives us 1.5. Since there's a remainder here, we'll write down 1. 1 divided by 2 is 0.5. You have a decimal, therefore we can conclude that there's a remainder. And finally, if we take 0 and divide that by 2, we'll end up with 0. This is read upwards. And finally, we have 7 divided by 2. That gives us 3.5. This is a decimal number, so we will assume that there's a remainder. 3 divided by 2, notice that we're only taking the integer portion, is 1.5, another remainder. And 1 divided by 2 gives us 0.5, another 1. This is read upwards, giving us a final number of 111. This set first, then this set, 110, 0, 1, 1, and 0, 0, 1. In the next question, we have 63,150 as the octal number. 63150. Starting with the 0, that simply translates to 000. Moving on to 5. 5 divided by 2 gives us 3.5, read as 1. 3 divided by 2 is 1.5, also read as 1. 1 divided by 2 is 0.5, also 1. The next one, 1 divided by 2 is 0.5, that's read as 1, and subsequently the next two will give us 0. Moving on to 3. 3 divided by 2 is 1.5, read as 1. 1 divided by 2, we'll take the integer portion. That gives us 0.5, another decimal. And 0 divided by 2, well, we know that will give us 0. And don't forget to keep track of these. So this is the first set, second, third, and now the fourth. That being said, 6 divided by 2 is 3, reads as 0. 3 divided by 2 is 1.5, that reads as 1. And 1 divided by 2 is 0.5, that reads as 1. Therefore, your final answer, starting from this set, is 1, 1, 0, 0, 1, 1, 0, 0, 1, 111, and 000. Now let's move on to question 2. In question 2, we have to convert the binary numbers to octal. This requires a little bit more time. So starting with this binary number, and to do this you have to split the binary number into groups of 3. So this one's already in a group of 3. This one will be easy. We'll start off with this one. 1 times 2 to the power of 0 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 2. We know that anything times 0 goes away. 1 times 2 to the power of 0, 2 to the power of 0 is 1. So that's like saying 1, and 1 times 4, the answer to this is 5. So the octal number here is 5. That one was easy. So let's move on to a more complicated one, B. Like I mentioned earlier, you want to split the binary number into groups of 3. So starting from the right, we have 0, 1, 1, 0, 1, 1, 0, 1, 0, 1. And this 1 doesn't have any numbers to the left of it, so we assume that the leading numbers were 1, 0. Therefore, we have 0, 0, 1. Starting with these 3, and then these, following those, and lastly those. These 3 binary numbers should give us 6. These 3 binary numbers should give us also 6. These will give us 0. These will give us 5. And these 3 will give us 1. Therefore, our final answer is 15066. And there you have it. 4 examples on how to convert between octal and decimal.